Hello everyone, my name is Abebual Molla. I'm a PhD student in Sungkyunkwan University. Today I'm going to present about actions and optimization practices to be taken for improving energy efficiency in soft drink industries. In my presentation, I'll try to cover introduction about soft drinks, general production process flow diagram of uh, soft drink, and the major energy intensive equipments in the industry, then the global soft drink consumption, energy loss and inefficiency use of energy, and finally I will try to cover actions and optimization practices to be taken for improving energy in the industry. Let's start with introduction. A soft drink is a beverage made up of carbonated water and a sweetener and a natural or artificial flavoring, a sugar, high fructose corn syrup, fruit juice, and a sugar replacement in the case of diet drinks, or a mix of these can be used as a sweetener. Caffeine, colorings, preservatives, and or other additives may be present in soft drinks. In contrast with alcoholic beverages, soft drinks are referred to as soft, or since alcoholic beverages can be called as hard drinks. A small amount of alcohol may be present in soft drinks, but in many nations, the alcoholic concentration must be less than 0.5% of the total volume of the drink. So it seems to be non-alcoholic. When we come to the general production process flow of soft drinks, the production process of soft drinks differ by product type and application, but the basic and the general process is the same. So it has flavor or concentrate water tank. So after that there will be a mixing, and there will be a carbonizer. Here we use carbon dioxide. Then it will be filtered. Next, the filtered will go to the containers are warmed. Then packaging, palletizing, and finally shipping. So this is just a typical process flow diagram of a soft drink bottling facility. Now let's see the raw materials of a soft drink. Commonly, the major raw materials are water. We have also carbon dioxide, flavors, uh, colorants, and sweeteners like sugar, acidulants, and uh, finally preservatives. So these are the major raw materials of soft drink. Now let's see the major energy intensive equipments in the industry. So in soft drink industry, the major equipments or processes and systems that are energy intensive include pumps and chiller heat and heat exchangers, mixing tanks, and boilers, bottle washer, like this. They are really highly energy intensive equipments. Motors, waste heat recovery, waste and wastewater, buildings, lighting, HVAC, compressed air, fans, drives, electricity distribution systems. So these are the major and the main equipments, process and systems that highly uh, energy intensive. So each equipment has annual electrical demand. So for example, for air compression here, I try to show with pie chart. So we need to conserve this energy to have best efficiency. Now let's see the global soft drink consumption. As we see from the graph, the soda consumption by volume is increasing year by year as the population number is increasing. So since different energy consuming equipments are used in production process, the energy pattern is highly affected. This can be due to different reasons like handling of raw materials, manufacturing process, and equipment handling. So this shows the increment of soft drink consumption throughout the world. However, as the rate of consumption of soft drink increases, the energy needed to produce the product will be high, which in turn increases the energy loss and also energy inefficiency use. So we need to have a solution for this. Now let's see energy loss and inefficiency usage. Energy loss and inefficient use of energy will have the following impacts. For example, in environment, in quality, price, and energy costs. So it has high impact. So it will have impacts in increasing carbon footprint, increased risk of climate change, higher energy costs, limited production capacity as a company or as an industry. It also impacts the market share of the company. Product quality will be affected and the price also will be affected. So these are due to the energy loss and energy inefficient use of energy. So to solve this, what are the actions and optimization practices to be taken for the major equipment that we are using on the industry? Here I will try to summarize for major equipment. I will start with pumps. So in pumps, we need to conserve energy. For that, we have to operate pumping near best efficiency point of the pump. We need to modify to minimize throttling, adapt to wide load variation with variable speed drives or sequential control of smart units. We need to stop running both pumps if we have different pumps and add an auto start for an ongoing or online spare, or add add a booster pump in the problem area. So these are some of the points that we need to do to conserve energy for pumps. When you come to for boilers, uh, we need to preheat combustion air with waste heat around 22 degrees centigrade. A reduction in flue gas temperature increases boiler efficiency by 1%. We need to use variable speed drives on large boilers, combustion air, fans, and with variable flows. We need to also burn wastes if permitted, and insulate exposed heated oil tanks. These are some of the other mechanisms to conserve energy in boilers. For heat exchangers or chiller, increase the chilled water temperature set point if possible. That is one way of conserving energy, or one of the action and optimization practice. The other one is use the lowest temperature condenser water available in the chiller. So these are some actions and optimization practices to be taken for pumps, boilers, and chillers. For a steam system, we need to use back pressure steam turbines to produce low steam pressure. Ensure process temperature are correctly controlled. we have to maintain lowest acceptable process steam pressures, reduce hot water wastage to drain, and for insulation, we need to repair damaged insulation parts, insulate any hot or cold metal or insulation, and we need to replace wet insulation here in insulation part. For the waste heat recovery, recover heat from flue gas, engine cooling, water, exhaust engine, low pressure waste, steam, drying oven exhaust, boiler blow down, etc. And the next one is recover heat from the incinerator of flue gas, use of waste heat for the fuel oil heating, preheating, boiler feed water heating, outside air heating, etc. So this is the other way. And use chiller waste heat to preheat hot water in waste heat recovery. These are some points for the, the energy efficient use in the waste heat recovery. In lighting, when you come to lighting, we need to reduce the illumination levels to standard levels using switchings, and we have to delight aggressively control lighting with clock timers, delay timers, photo cells, and or occupancy sensors in the industry. Install efficient alternatives to incandescent lights, mercury vapor lights, and etc. Now let's see for heat ventilation and air conditioning. We need to tune up the HVAC control system, consider installing a building automation system, BAS, or energy management system, EMS, or restoring an output of service one. These are some points or some mechanisms. And the other one is balance the system to minimize flows and reduce blower, fan, pump, pump power requirements, eliminate or reduce reheat whenever possible. Use appropriate HVAC thermostat setback. So these are the actions and some optimization practices for the major systems and equipment. There are also a lot of equipment. Just I try to come up with the few ones. When we see energy conservation, it is the effort made to reduce the consumption of energy by using less of an energy service, and efficient energy use, sometimes simply called energy efficiency, is the goal to reduce the amount of energy required to produce products and services. Therefore, applying the above tips, like different mechanisms, we need to save energy, conserve energy, reduce energy costs, financial costs, saving to customers, energy savings, additional costs, saving, and will help us to have best energy or efficient energy usage. So here I just try to show the saving tips, energy saving tips, the basic energy saving tips recommended for manufacturers. We need to consider the following when we are thinking about energy saving. So the first one is lighting in the industry, and the next one is turn off and run equipment when only required, unless otherwise we need to turn it off. The next one is reduce closing door delay, clean and maintain equipment, air conditioning and heating, insulation. This is also the best way of saving energy. Shade windows with some insulation and also the wall. Replace existing lights with LED lights. Use natural airflow in the industry, and also check air conditioning lines. Optimize appliances. Make it collaborative, not to top down. So these are some tips for manufacturers to save energy. This shows the sector needs to be more research and more findings must be done in the future. So technological upgrade in the soft drink industry for energy efficiency and energy improvement will be done on production process of soft drink equipment. We can also improve the quality of equipment that we are using, and we can also use or technologically upgrade the raw materials. So technological improvement on this will help increase energy efficiency as a whole. Here I just try to show some reference. Thank you for your time. Thank you.